Okay, we're going to look at the same problem that we just worked with a confidence interval and run it as a hypothesis test. If you recall, the American officials were suspect of the Japanese charging more for their cars in their own country than in the United States. And with the confidence interval, we wanted to estimate the difference in those average prices. But approaching this problem with a hypothesis test, the U.S. officials would like to see if they could prove that the average price for the automobiles in Japan is greater than the average price for the automobiles in the United States. Now, they may be right about that, but they can't strictly base it on the point estimate, the x1 bar minus x2 bar. Those are averages just taken from samples. 50 samples from Japan, 50 cars from Japan, and 50 from the United States. It does appear from the sample that there might be some evidence that the average price of the cars in Japan is greater because when I take the population 1 sample average, subtract the population 2 sample average, I do get a positive 640. So, but I can't go ahead and make the conclusion or draw the conclusion that they are indeed higher. X1 bar and X2 bar are estimates. They're not mu1 and mu2. If I knew what mu1 and mu2 were, the actual population averages, I would know exactly what the difference is, and there would be no reason to run a test or build a confidence interval. I would have the exact information. But the real question is this $640 strong enough evidence to go ahead and statistically conclude that Japanese averages for their cars in Japan is higher? So to do that, I'm going to run a hypothesis test, and also just reminding myself here that I do not have the population variances. I have sample variances. In particular, I have sample standard deviations. So to proceed with a hypothesis test, I have to think about what am I trying to show here. And I'm trying to show that the Japanese are charging more for their cars on average in Japan than in the United States. So I'm trying to show that mu1 is greater than mu2, which is the same thing really as trying to show that mu1 minus mu2 is greater than 0. So if I want to show that mu1 is greater than mu2, I'm going to show that their difference is positive. So what I'm going to do is set the null hypothesis and the alternative hypothesis up here. And again, what do I want to show? I want to show that mu1 minus mu2 is greater than 0. So the null hypothesis is that mu1 minus mu2 is less than or equal to 0. Now it's important to stop here and consider how I'm setting up this test. I want to show that mu1 minus mu2 is greater than 0. I want to show that, or if I can show that mu1 is greater than mu2. Remember that when you run a hypothesis test, we're not going to do a type 2 analysis here for any of these two population tests that we're running in Chapter 10. So to show something, it's got to be the alternative. Because remember, the conclusion will be either to reject the null or do not reject the null. So when you run a hypothesis test, you'll never be able to prove the null hypothesis. And since what we want to show is that mu1 is greater than mu2, or that mu1 minus mu2 is greater than 0, that has to be the alternative hypothesis. So step 1, I've got my setup here. And in step 2, I'm going to think about what the sampling distribution is. And this is the same distribution that we used in building our confidence interval. We're testing now. We're running a hypothesis test. So we're going to center this at 0. And my S sub x1 bar minus x sub 2 bar, using my formula that I did before. And this would be the 1974.09 squared over 50 plus the standard deviation from the population 2 sample, 1981.44, and I'm going to square that, and that will be over 50. The sample sizes were the same. Remember, from that, I got the 395.55. So that's my standard error. Notice that this is an upper tail test, and I'm going to run on alpha equal to 0.05, and this is going to be a t distribution. My t value, my t sub 0.05. Now, different than the confidence interval, I'm not splitting that, so I've got alpha 0.05, and my degrees of freedom was calculated with the degree of freedom formula when I was doing the confidence intervals, and we know that was 97. So looking up under column 0.05 and in row 97, I get 1.661. Again, notice that that's different than the value I got with the confidence interval because I'm not splitting alpha here in the one-tailed hypothesis test. So my t value at this particular marker with 5% on the upper end of the distribution is 1.661. This is my critical value. Now I'm going to go ahead and write my rejection rule. I'm going to reject h sub 0 if my test statistic t value is greater than my critical value t value. And in step 4 we'll find out what that is. That's the 17,236 minus, we're estimating the difference, so minus the 16,596, and then we are comparing that to 0 and divided by my standard error, the standard deviation of the sampling distribution. So I basically have 640 divided by the 395.55, and I get 1.62. And that is almost but not quite. Do not reject h sub 0. So in some sense it's inconclusive under an alpha value of 0.05. Inconclusive. I cannot say that the Japanese are indeed charging a higher average for their cars in Japan as opposed to the United States. At least not with a alpha value of 0.05. I cannot say that. Now, just for a moment, I want to take a look again at the confidence interval for this problem that we did earlier. Notice how the confidence interval, this 95% confidence interval, really allows for the mu1 minus mu2 to either be positive or negative. In some sense being inconclusive as to which one is larger, either the mu1 or the mu2. Now, there's stronger evidence that the mu1 minus mu2 is greater than 0, that Japan is charging more for their cars in Japan, but not under a 95% confidence. So when we set a hypothesis test up with alpha equal to 0.05, we really, in some sense, agree with that confidence interval in our conclusion. It's inconclusive. We really don't have that 95% confidence. And we are not willing to take the risk of rejecting the null and making a type 1 error, claiming that Japan is charging more for their cars in Japan when they aren't. We don't want to make that mistake. So with our alpha 0.05, we're not willing to take the risk and claim that's true. Our conclusion then to the problem would be, for alpha equal to 0.05, we are not willing to reject h sub 0 and claim that Japan is charging more for their cars in Japan than in the United States.